All right, these geometric mean notes is going to kind of piggyback off of what we did with similar triangles and proportions. Okay, so just remember that a proportion is two ratios that are set equal to each other. And when a proportion is true, that means that their cross products are equal to one another. Okay, so when we look at this first proportion here, 4 times 12 is 48, 3 times 16 is 48. Since those cross products are equal, yes, that is a true proportion. But here, this one, 9 times 8 is 72. 4 times 13 is only 52. So since those cross products are not equal, this is not a true proportion. Okay, but the geometric mean is when a positive value is repeated in a proportion. Okay, so in this instance here, since x shows up once in the numerator and once in the denominator, all right, once in the numerator, once in the denominator of the two different ratios, that means that x is the geometric mean. Okay, between 4 and 9. Okay, now solving these geometric mean proportions is just like solving any other regular proportion that we've done in the past. Okay, we cross multiply. Okay, the only thing that we need to pay attention to, x times x is actually x squared. Okay, 4 times 9 is 36. And to undo squaring, or the inverse of something being squared, is to find the square root. Okay, so in this case, our x value is 6, which means that 6 is the geometric mean between 4 and 9. Okay, so some examples here. When we are trying to find the geometric mean, that means x, or a variable, shows up twice. Okay, just like we did above. Okay, so we want to know the geometric mean between 4 and 16. Okay, what I like to do, my first number here goes in that first spot. My second number here, 16, goes in my second spot, or I guess the bottom right, top left and bottom right here. All right, and then my variable fills in the other two pieces. Okay, we cross multiply. X squared, 4 times 16 is 64. And then we find the square root. So here, 8 is the geometric mean between 4 and 16. Okay. Next one, we want to find the geometric mean between 8 and 18. Okay. So 8 fills in my very first spot. 18 fills in the last spot of my proportion. My variable fills in the one top and one bottom. We cross multiply. X times x is x squared. 8 times 18 is 144. And we find the square root of both sides, which means x is 12. So 12 is the geometric mean between 8 and 18. Number 3 here, we want to know the geometric mean between 3 and 27. The x's need to be diagonal from one another, and then the two numbers that were given need to be diagonal from one another. Okay, we cross multiply. If x squared is 81, That means x is 9, so 9 is my geometric mean between 3 and 27. Okay, but some of these last couple examples here, now we are given the geometric mean. Okay, so remember, whatever the geometric mean is, so since here 10 is the geometric mean, that means 10 shows up twice, once in the numerator, once in the denominator. Okay, now we want to know the geometric mean between 5, so 5 fills in one of the blank spots, and what number? That means our variable fills in the last spot. Okay, we cross multiply. 5 times x is 5x, 10 times 10 is 100, and then here this is pretty similar to what we did with similar triangles. So our x value is 20. Okay, which means 10 is the geometric mean between 5 and 20. Last example, we have 12 is the geometric mean. Okay, so 12 is what shows up twice in our proportion. Between 16 fills in one of my blank spots, and what number means my variable fills in my other blank spot. Okay, 16 times x is 16x. 12 times 12 is 144. And then we divide both sides by 16. And 144 divided by 16 is 9. So 12 is the geometric mean between 16 and 9. And now you will go do your DMR over the same kinds of problems.